Hello, everybody. Mostly watching the recording, but thanks for y'all that were able to join. My name is Chad Kroll, and this is on the Austin Kubernetes community group. So our short link is the katesaustin.com. Kubernetes is commonly abbreviated to K8S, or Kates is what we all call it. And so, we're running. We have a couple meetings actually on the schedule for this coming later this month and also next month. So that's where you can go to find out more about those meetings. We usually meet in person. We're doing a little bit different of a format today, obviously, in doing this recording. And Patrick was nice enough to lend us his time, so we'll get into it. So this is an official CNCF Cloud Native Computing Group meeting. So as such, we will follow the CNCF Code of Conduct. It's pretty easy. Just be respectful of each other, and we will be respectful of you. Even if you're watching this on the recording, making comments and such, just be mindful of that code of conduct. Reach out to us. We are the organizers of Austin Kubernetes Community Group. It's me, Chad Kroll. I'm a platform engineer at CVO, and my co-host, who was unable to join today, he's vacationing in Portugal. So I'm very jealous. But yeah, his name is Rafa Brito, and he's from Stormforge. He's an engineer over there as well. And we, like I said, we usually run these meetings in person, and we'll get into that later on. But today we have Patrick Smyth joining us, and what I know about Patrick from our brief conversation just before this recording is that he's obviously a staff developer relations engineer at Chainguard. He was born and raised in Queens, and that's where he's reporting live from today. So he's in the northeast of the U.S. He was also a researcher at Columbia University. He also has a PhD, so I guess I should have said Dr. Patrick Smyth. Sorry. And did PhD in digital humanity from Columbia. So welcome, Patrick. I will try to shift the screen over to you and let you introduce yourself.
All right, folks. So we're going to talk about AI defense and production today. I am staff developer relations engineer at Chainguard, where we create the most secure images in the world. And in our opinion, but we've been kind of moving into this area of AI images, and they have some really interesting special considerations. So we're going to talk today about, and this is, Chad already gave me a great intro, but I don't know if I need to add anything to that. You can find me either playing with my 6-month-old daughter outside of work. You can find me playing with my 6-month-old daughter, or swimming in a frozen lake. You can reach out to me on X at psmyth, and my last name was with a Y, so PSMY as in yellow, TH01. So today we're going to be talking about, first of all, thinking a little bit about security in Kubernetes. If people want to, I know it's kind of a tradition to talk about that pronunciation. So if anyone wants to criticize my pronunciation, that's fine with me. We're going to talk a little about security in general and some of the trends there. For also why AI images are relevant, especially now in 2024. Kind of obvious that there's a big AI upswing, but I've got a couple of numbers and stuff to support that. We're going to talk about our Chainguard images, our philosophy on that, our distroless philosophy, and do some comparisons. And then we'll do a demo. I also have about 6 terminals open here with different scanner outputs and so on that I think are actually pretty interesting. In some interesting breakages of infrastructure with some of these newer AI images that are extremely large. Okay, let's just go ahead and get started. So there's a Kubernetes in 2024. People have been mostly moving in the right direction in terms of security. So some of the biggest secure ways you can secure your infrastructure are to make sure you have configurations that don't set all these different privileges by default. And something that is maybe more of a concern with us, and this is what this very complicated chart shows, but I'll try to break it down a little bit. Is that CVEs basically, whether or not CVEs affect large numbers of workloads, so over 90% of workloads at a specific company, basically it has a bimodal distribution. So some companies are scanning, they're doing active CVE mitigation, and some companies are not. And that so there's kind of, if you see on this chart, you can kind of see a lot of people clustered down at that um, basically not affected by CVEs end of the spectrum, and a lot of companies are clustered at this high end of the spectrum. So, and I would say it's something like 30% of companies using Kubernetes right now have over 90% of their workloads affected by critical or high CVEs. So, and that's fairly significant. So, and it follows the same more or less bimodal distribution with things like uh, making sure that you don't disable all these security settings, so such as not running as root, et cetera, et cetera. Also follows a bimodal distribution. So it definitely seems like there's company cultures that have this, they have this culture of security, and there's company cultures that they're working on it, maybe they're getting there, but they're not quite there yet in 2024. So one thing that people have adopted a lot are scanners. So the big ones right now, and there's quite a few to choose from. They're getting very sophisticated, but CVE scanners, and I hate to use acronyms without explaining them, because not everyone, we're not all born knowing what CVEs are, right? CVEs, common vulnerabilities and mitigations, or exposures rather, and they are known vulnerabilities that can affect your software or your infrastructure. So, in terms of scanners, companies mostly using Kubernetes. They mostly do run some kind of scanning software on their images. Okay, so just to be clear, these are things like Gripe, Tri-V, and a fairly new addition, which is Docker Scout, which I kind of enjoy using. And some companies, at least they run one of these in the background. They will. These are tools that kick up CVEs. They tell you how many critical, high, medium, low CVEs you have. So companies are using these. And then we have CVEs. I could have had this up while I talked about what CVEs was, but like, you don't want CVEs. There's an obvious point, but you don't want CVEs because you're in the DevOps business, you're in the infrastructure business. If your images have known vulnerabilities, then they can be used as backdoors to undermine your infrastructure, to gain control of applications or workloads that you're running. It's not something that you want. I mean, it seems obvious to say you don't want vulnerabilities, but you really don't want vulnerabilities. You know what I mean? And it's not necessarily in this current landscape where we have these major vulnerabilities coming out all the time, and especially if you're in a business where you're selling to the government, for example, you have to go through FedRAMP certification. You want to be mitigating your CVEs. Okay. However, it's a lot of work. So that's basically what our company does is Chainguard. We offer Chainguard Images, and they are they are images created specifically with an eye on having what we say low to no CVEs. And so the images are freely available. The latest version of each image is freely available. So we have images for major languages, databases, server software, everything you need to put together your cloud infrastructure. We even have things like FIPS ready images. So if you need if you're working with the government, you need to be using FIPS, then you have access to those kinds of specialized images. If you work with us, we will help you build custom images. Or if you need to use older tags, then you work with us. But all our latest images are freely available to try out. Let's see, and then let's just talk about zero CVEs, like or low CVEs. I mean, we say no to low CVEs, but really, if you pull one of our images on any given day, chances are you have a very strong chance it'll be 0 CVEs on that day. And it's like, here's our, for a comparison, this is our Python image. And this is a week out of date now, but it's from April, and it is our last month's comparison of the official Docker image of Python with our Python image, Chainguard, our Python Chainguard image, and you'll see, there are high, critical high, medium, low CVEs in the Python image, usually around in the realm of dozens, and sometimes in the low hundreds. And ours has had 0, so it's crickets in there for the last month, which is pretty great. So when we say low to no CVEs, we do actually mean it seems, I mean, when I first started using Chainguard Images, it did seem impossible to me that you would just switch to a base image and then have 0 CVEs. But it is possible. So, I mean, and we do manage to do it. And I guess people always ask, like, well, how do you do it? Is it some like special technique or whatever? Kind of, but not really. Really, it's just old-fashioned toil. We call it toil at Chainguard, and we're always trying to reduce our toil for CVE mitigation. But really, it's just we have a great team of people who really know their stuff. They do a lot of hard work, and they're out there, digging ditches in the image mines and making sure that these images are as absolutely as secure as possible. However, there's a couple of other bits of our philosophy that we have. So one thing that really helps is and it kind of makes sense if you are telling people, hey, the image is low to no CVEs, then suddenly other things become much more important. So the surface, the package surface, or the maintenance surface of your images becomes really important. So you're not going to be just tossing packages in your images willy-nilly, because not only are you going to have to remediate CVEs, but our job is to get them down to 0. So we really think hard about putting extra software into our images. We want them thin, we want them light. And then that also means, as a side benefit, which will become more relevant later in this talk, because we're going to talk about the AI images, they're also smaller than most official images. Of course, we also do things like we write our own patches if necessary. We keep things extremely fresh, so we do nightly builds. Usually, software will be pulled in Wolfie OS, which is the Linux distribution that Chainguard Images is based on. Usually, if say there's a patch to a Python package or something like that, that's usually pulled in within 4 hours and then built overnight. So we keep things fresh. That's a big part of it. We'll patch things ourselves if necessary, and we also sometimes we get into that configuration layer and try to make sure that if a CVE can be remediated through changing configurations in the image, we also do that. So these are the things that we do to get down to that low to no special 0 number, which is infinitely better than any other. Okay, so Wolfie OS, it is it's free and open source Linux distribution. It is distroless. So what does that mean? Distroless is a philosophy for approaching distributions, and in our case, images, and basically means we take a bunch of stuff out by default. So we do that thing where we try to have as few dependencies as possible. That is part of the distroless philosophy. But in going further, we also don't run images. The images don't run as root by default. And this is kind of hard for people to wrap their heads around sometimes, but we also remove all package managers and interactive shells from the images. And there are what we recommend depends on what software stack. But you're like, how do I develop the software if I don't have access to those things? But basically, we recommend things and we educate people on things like multi-stage builds that allow you to use our developer image, which does have all of those things. And then in the build process, in your Docker file, whatever your build process is, you then use the software artifacts you build and you copy them into the image that has no shells, no package managers. And why do you do that? Because they're liabilities, right? Shells are liabilities, package managers are liabilities. They allow you to execute arbitrary code, and by design. And so ideally, you would not have them in your production image. Now, however, people always ask, well, what if I need to do this? What if I need to do that? Sometimes it is a problem that you don't have access to those things. And you can use our developer images for production, and you get the benefit of 0 CVEs. But you just don't get that little extra benefit from the distroless philosophy removing those things. Though once you start developing your infrastructure that way, it's a little hard to go back. It's a little hard not to see images with shells in them as somehow kind of inherently insecure. Though it is, for certain applications you need to have that, or certain setups. All right, so let's switch to AI. So AI is obviously it's big in 2024. It's moving from something that big companies are playing around with to something that is user facing in a big way. And this is a little stat that I pulled from this from a Datadog. Shamelessly stole this infographic from Datadog, so thank you. But basically says this year, 2024, has seen an increase it's about a 30% increase in non-image related GPU workloads. Okay, so people are using GPUs way more in 2024, but specifically for images, people are using making GPU enabled workloads have increased by 58% year over year. So what does that suggest? What does that discrepancy suggest? Well, first of all, we know that people are running more GPU workloads, so AI is getting bigger. But specifically, people are using images for their AI, even more so than it's just a big part of this move to production AI, running inference in the cloud. However, there's a lot of challenges related to this. So we have some special considerations that we'll go through. But really, the main ones are what we were talking about before, but this maintenance burden. Some of these images, we're going to look at specific numbers in a second, more specific numbers, but some of these images they're enormous. And we'll get into just exactly how enormous they are. But they have a huge surface area, way more so. And we're talking about images that are gigabytes and gigabytes, okay? And up to, 17 gigabytes compressed, so on. And they have, in some cases, the high hundreds of packages. This is a huge surface area, a huge maintenance burden for security because there's so many packages in these images. In addition, because of the size of these images, because there's so many packages in them, the size in the compressed and uncompressed size in bytes is also enormous. Now that has some more specific implications I'm going to get to. I have a whole bunch of terminals open here that I want to show you in a sec. Some real world implications of that. But basically, yeah, it affects your infrastructure. That once you get over a certain threshold in image size, it starts to break specific tools. And maybe in 3 years, in 1 year, 2 years, or 3 years, 5 years, people will be more used to these big images. The tooling will have caught up. There'll be more closed PRs or whatever. Everything will be fixed. But we're not there yet. Things break at these large image sizes, and we're going to kind of investigate that a little bit. So here's a quick comparison of our two images. So it's the official PyTorch image released by PyTorch organization, and we have our Chainguard image, which is called PyTorch CUDA 12. So it's the CUDA powered PyTorch image. And we're comparing the runtime. So this is not the developer version of the PyTorch official image. And we have ours is 3.3 gigabytes. Theirs is 4.1 gigabytes. So a little under something like a 20% reduction in the size there. That also can matter a little more than you think too, because that's the compressed size. And then the uncompressed size can be, in some cases, significantly larger than that. So it can actually come out to a lot on the other end. And then possibly more of a discrepancy is PyTorch official images includes all sorts of packages that are, they're indisputably they're useful. There's Jinja 2 templating, there's the dashboard creating package, there's all sorts of stuff. It's indisputably useful. But however, are you always going to be using the dashboard creation Python package when you use PyTorch? I personally think the answer is no. You might use it sometimes, but does it need to be in there by default? Very possibly not. And it, every time you add one of those packages, it adds more maintenance overhead to your images. Okay, so the PyTorch official has 225 packages currently. Ours has 68. That's using, it depends what tooling you use to because some tooling counts different things as different packages. But I use Gripe for that analysis. So, but it's I always use Docker Scout about the same, just plus or minus 10% or something like that. So significant reduction in the maintenance overhead and the potential attack surface in the image. So this is something I think will be talked about more. I'm preparing a blog post on it, and I'm hoping it will go out maybe in June. Doing a little research, but large images are increasingly relevant, and in AI, they're quite relevant because many AI images are quite large. So I'm kind of just making up terms for these, but I would call a large image anything over a gig, kind of a large image. And between that, like gig and so some things mostly work in that large. So 1 gig to 5 gigs, I would say. And this is anecdotal. I will hoping to have a little more of a formal research, put my research hat on, and have a few more rigorous tests in this blog post. I do have some consoles open to show you that the results of running of scanning and doing some other things with these images that I'll show you in a second. But at things kind of work certainly up to a gig. That's great. That's the size you want an image, right? I mean, you want small images ideally if you can. A gig to 5 gigs, things still mostly work. When you get into this, what I would just arbitrarily call very large area is at 5 gigs to 10 gigs. And then you start seeing maybe some hinky stuff. There's a GitHub issue that was just closed on Trivy that is on the PyTorch image. The PyTorch image kind of it's still in this, it's just about in this very large area. And certain things were breaking. They mostly got fixed and stuff in terms of scanning the PyTorch image with Trivy specifically. So at that size, there's some issues with very large files in the image. So I think there was an arbitrary limit of 200 megabytes on a specific file. It can be adjusted, but that's the arbitrary limit. So things get a little trickier at these larger sizes. Now, then if you get into ultra large or mega large, I wrote mega large here. Maybe ultra large might sound better, whatever you want to call it, whatever Latin prefix you want to put on that. I'm arbitrarily setting it here at 10 gigabytes just because that's indisputably very large. Okay, it's also the default file size limit for the writable layer in Docker, but it's not totally related. But yeah, 10 gigabytes is a nice number. It's also the number at which Docker Scout, which is it's a popular scanning software. It's newer, but it's popular. They have chosen 10 gigabytes as a cutoff. An automatic scan they won't run on an image that's larger than 10 gigabytes. Or if you use Docker Desktop, they also won't run it. The only way you can use Docker Scout to scan one of these images that's over 10 gigabytes is to use the CLI. And then, as we'll see, sometimes that will work, sometimes that will not work. So we have supersize me. So these images are, maybe I'm dating myself, but this is I think I was a teenager when these were big, but McDonald's offered supersize fries that were way bigger than anything else. But these image containers, just like these French fry containers, are getting very large in 2024. Okay, so I want to go to demo here a little bit. You can follow that link to go to our PyTorch CUDA getting started. Before I actually run a workload on our image just for fun, I am going to walk you through some of these different like implications of scanning these large images. Okay, so I'm going to start with our PyTorch the official PyTorch CUDA 12 image. I have a scan result here. So this is Gripe, Grype. If you haven't used it, it's pretty solid. It's also in the tests on the very large NeMo image that I'm going to talk about in a second. It's the only one that actually managed to scan the image. So good for Gripe. It's also the one that we like to use the most at right now at Chainguard, but it's released by Anchor. It is So let's just take a quick look. So what are the current? So okay. So luckily we have no critical, but we have 20 high vulnerabilities. So that's a fairly significant number of high vulnerabilities. And how many medium? That's a lot. 162 medium. That is a lot of medium CVEs. And then lows are lows. But yeah, right now, why is there so many CVEs in this image? And I would say my answer would be it's really, really big. It's a really big image. It was last built, I think, maybe a month, like 70 days, something like that ago. And it's huge. And it has a lot of stuff in it. So, and it's hard to keep all that up to date. And because it has such a big surface area, it has a lot of CVEs. So it's not even really that surprising. And these images, they're created for functionality, and they're created for researchers in a lot of cases. People are running training on them with them, which is fine. But then when you get into inference, when you're putting things into production, you don't want hundreds of CVEs. And also, if you're doing something, if you want to be a vendor for government agency or something like that, it's just not going to fly. They're not going to let you have this number of vulnerabilities in an image in your stack. It would go against your agreement. So all right, so let's look at the R image. So this is also a gripe scan for our current Chainguard image, and I will say it's in beta now. When I wrote the tutorial for this a couple of weeks ago, we had 0.0.0.0, and now I feel a little bit like that. When in Japan, when a train is late by like a minute, they will issue a national apology. So I do kind of issue a national apology because we have 3 medium in here. So I might say that's pretty good. Couple hundred to 3, and we have no highs. But it is embarrassing because we like to have 0. We go for 0. Chainguard images usually have 0. So the fact that we have 3 medium that popped up this week and haven't been remediated yet, it's embarrassing. So I issue a national apology for our 3 medium here. But it's I think you can see the difference here. We have many fewer packages by like 5 times almost 4 or 5 times fewer packages in the image. That makes a really big difference, and we do all the other stuff that I was talking about earlier. So it is in beta, so we're still working on these, but I think they're already kind of in a pretty good place. And you can pull these images too. We're gonna use that image to run a workload. So this is interesting. This looks like nothing. This looks like I did nothing, but this is the result of using Docker Scout on not the PyTorch image that I've been showing you before, but the NeMo image. So NVIDIA NeMo is a new conversational AI framework by NVIDIA. It's pretty cool. It has everything in the kitchen sink in it. It does so conversational AI, that's stuff like TTS, automatic speech recognition, NLP, natural language processing. It also does multimodal models, so kind of a mix of different things. It's a great framework. I recommend playing around with it. The image for it, it's a big framework. The image for that framework is 17 gigabytes over the wire, so compressed. And that's big. That's a very big image. And when we run Docker Scout, we do a Docker Scout CVE scan on it. We get this output, which is that it tried and then it just didn't even return any errors or anything like that. So, I mean, I could try to rerun this with verbose or whatever, but it failed. It did not work. Docker Scout does say it won't scan images on Docker desktop or with their automated CI scanning tool over 10 gigabytes. But it does say you can do it on the command line, on the CLI, and this is what I've done here, and it still didn't work. But it is a huge image, so, and it's not surprising that infrastructure fails. I mean, to scan, things have to be indexed, so to some extent they have to be loaded into memory. There are timeouts and stuff. We're programmers. We put timeouts and things, stuff like that. This ran for about, I think, half an hour, and then it failed. So, I haven't dug in yet. I'm going to make an issue on Docker Scout. I'm going to make an issue on Trivy now in a second as well. I'll show you that in a second. But it's not surprising that these fail because it's so far outside of the median image size But that's, this NeMo, and also another really huge popular AI framework, which is Hugging Face Transformers for open models, right? Is just over that, what I would call that ultra large, mega large threshold of 10 gigabytes. It's just over that. So it's also really enormous. So I think these will become increasingly common because these AI images, they just have these big shared libraries, big SO files stuck in them. So they're just enormous. All right, let's quickly look at the Tri-V output. So the Tri-V output is a little more verbose. It looks messier. Docker Scout output was really minimal, like just brief, and it had nothing. But basically, this says, this reads to me like a timeout. It's hard to say. I haven't dug deeply into this. This is probably worth, when I file an issue, I'll dig into it a little bit and see if I can figure anything else about it. But basically, and I've also tried running this with without what they call without secrets. So because that increases the scanning time if you're looking for secrets being included, which is a cool thing that Tri-V does. I have also run this without with that flag enabled that they recommend if things are taking a long time, and it also got the same results. So and the original command is up here. But yes, so basically the point here is very large images, and it's many of which are AI images. Some of other large images are things like OS type images and stuff like that. But in these, with these AI images, in theory, you would like to be including these images as part of your production application. So the fact that they break infrastructure is, I think, a problem. And I mean, NVIDIA does offer their own cloud thing, so maybe they're not as worried. If you use their cloud platform, maybe this isn't as much of a problem. Maybe they're not as worried. But if you are running it on anyone else's machines, or you're trying to do, you're trying to use all different kinds of infrastructure with it, I wouldn't be surprised if many other things broke. I also used Dive, which is a container inspection tool or image inspection tool, which breaks down the different layers in image, and it also futzed on this giant image. It didn't work on this giant image, and in fact, I had to restart my laptop because the entire machine got locked and just ran out of memory or whatever. So, and this is a pretty beefy developer laptop, so. All right, so now let's quickly talk now about here's one more. Okay, so we're going to this is me downloading the image, so hopefully that worked. So we'll try some demo here. We'll see how far we get. What's our time check here? 140. Well, we may not have time for a full demo here. I guess what I'm going to do is do a little tour through the our getting started. So if people want to try it, I'll just do a quick 5 minutes. I won't actually run the workload since it takes a little while, but I'll kind of walk you through. So let's get out of GCP there. I was gonna. So this basically is our getting started with our PyTorch CUDA 12 image. So PyTorch running on the CUDA 12 computing substrate platform, whatever you want to call it, by NVIDIA. And we'll walk you through pulling our images, checking that you have access to your GPUs, which is here. And then we will also walk you through detecting some animals. So you can download some. Basically, I'll show you here, but there's a giant blob of command that will basically download some sample data of 3 different animals, which we picked: penguins, octopus, and whale. And it will grab one of these pre-trained image detection models, and then we fine-tune the model using those 3 animals, and kind of and then it can be used. Then you run it in inference and then detect octopus, penguin, whale, whatever. It'll tell you whatever the output is. And there's a little comparison here as well of the the number of CVEs and so on. So I would say if you're thinking of doing inference in your application, or you have a model, you want your application to be powered by AI model running an inference, then I think this is an amazing choice because we have fewer packages, we have low to no CVEs. It won't break your scanner because it's much smaller if you're using the NeMo image. Currently, the official NeMo images probably will break your scanner. You probably will not be able to scan, so you're going to be in that. You won't be in. You'll be in that 30% of people who are affected by CVEs, or even worse, you'll be in that 16% of people who aren't running scanners in their current Kubernetes setup. And so I kind of recommend. Right now we're in beta. It's May. We're going to be doing a big launch in June. But if you're interested in playing around with these, they are freely available to download. You can if you Google Chainguard Images PyTorch CUDA 12, you'll have instructions for grabbing that in the image overview, or there's instructions here in this getting started guide. And they're available to the public. You can play around with them. If you're thinking of doing something serious with them, reach out to us, just because we would love to collect your feedback during the rest of our beta. And yeah, look forward to us having. And we're still making a few improvements. We're changing things, so look forward to us having some pretty slick images to be used for your AI workloads in mid-June. So, and that's my presentation.
Cool. Thanks so much. I do have a couple of questions. Do you
Yeah, of
mind?
course. I'll
So in
keep
the
sharing my
context,
screen just in case I can pull up a console or something like that.
yeah, definitely. So in the context of distroless and minimal container
Yeah.
images, where do you find, I guess, speaking on behalf of Chainguard, where's like the happy medium where you're able to run a container that is minimal, but also able to, install some packages for debugging, for example?
Yeah. Okay. So it's funny. I actually had a slide for this from previous presentation that I removed. But the tooling for debugging distro. First of all, I will acknowledge that it is painful not to have your familiar tools like your shells and your package managers and stuff when you're debugging. So I just want to acknowledge that it's not always the easiest thing first. However, the tooling for debugging distroless containers is getting really good. So something I've been using lately is something called CDebug. So letter C, debug, and it's container debugging tool, and among a bunch of other things, including some really nifty stuff related to simulating network traffic and stuff like that, which is pretty great. It allows you to run kind of a pseudo shell within a distroless image. So basically, what it does is it sideloads a bunch of tools in. And which you can always do yourself. Like, no one is stopping you from manually you run people do this manually, run the container as root, go put a bunch of stuff in that bin folder, and then you'll have so temporarily have your in a volume. So then you temporarily have your your familiar Unix tools like ls whatever, and your interactive shell and your all that stuff. However, it's kind of a pain. So CDebug will do that kind of by default. I was using it just a week or two ago to debug one of our images. And another one is, this is the Kubernetes meetup. There's ephemeral containers, which is a great tool to. I'd say if you're probably if you're listening to this, you're into Kubernetes, that's the one to use for you. Docker has come out with something they call Docker Debug. That's the one I would use by preference. But I will say it does require a pro account. Okay, so you need to have access to Docker Pro. So that's kind of unfortunate, but if you have access to Docker Pro, it's a great tool, and it will do the same thing. It will, without changing your image, it will allow you to basically act as if you had a shell in the image to debug it. And I guess, I don't know, in terms of building things, there's also a lot of pain points. There's different options you have basically to, our Wolfie OS is free and open source. You can build images from scratch on there and put whatever packages you want in there and get them in the form that you want. Before you get to that Docker file level, you can, or you can work with us. We'll build you an image. That's kind of our bread and butter as a customer. Or for specific stacks, there are ways of working around this. For Python, which is one I've just written a guide and stuff for that. But basically, you can do a multi-stage build. So you use a virtual environment. You put all your pip packages and stuff in there. You copy it over. use the dev image, which is very similar to the production image, except it does have shells and stuff and package managers. And then you copy everything over in the last step, and then you have a really hardened image that has no shell, no package manager, but you do have that environment.
Yeah. So for the Go and Python images, for example, that you're taking and kind of, I guess the question is, how do you build those new images from scratch, or are you taking a copy of like the Python official image and doing something to it?
On our end, we build from scratch. So we're basically down to the, we have originally we used some Alpine because they're pretty minimal and so on. And some of our stuff is sort of based on Alpine APK, the Alpine package keeper, or infrastructure. But we're now all on our own, all the way down to the base image, which would be Wolfie OS. And Wolfie OS is just that minimal distroless, first distro. And we have, you'll also find we're adding packages to Wolfie every day. So you can open an issue with us if you think there's something obvious we don't have. In some cases we will be like, okay, you'd have to be a customer or something like that. But like if it's something that probably should be in there, then you can open an issue and we may add it. But yeah, so yeah, we everything is our own, from bottom up is our own, developed and maintained infrastructure at this point.
Cool. When you're trying to reduce the binary count or the package count, is it simply scanning the image and then determining which contain CVEs and which do not, and then removing those? Or I guess how does Chainguard determine which packages should be removed and which are left there,
I mean, I guess we start with as minimal as possible to run some basic benchmarks, right? Then we have different teams for this. So we have a delivery team, we have a customer success team that works more directly with customers, we have an infrastructure team, and so on. Basically, there's a whole life cycle of an image, our image factory life cycle, where we move from creating an initial image that can basically run something, to maintaining the image, to we're getting a lot. We try to be a little customer driven. So if customers are requesting that things be in an image, we might not just add something in just because one person asks for it. That's more the realm of a custom image that we would create for a customer. But if people are asking for things over and over, then we add it into the image. So we're customer driven. So it's a hard line, because I mean, I'm a developer, and you want your affordances. It's frustrating when you reach for a tool and you don't have it. I totally get that, but we try to walk a line that is more on the side of having fewer things. And if people want more stuff, then we do offer those developer images. I mean, once you hear, oh, there's these production images, then you want to use them. But you can totally use the developer images in production. They are secure. They're way more secure than, miles more secure than the official ones. They're still way more secure than other people in the industry who are actually looking at security by, I think we estimate 20%. And all you're just not getting is that distro list. But then once you see that distro list, you do want it. But yeah.
Yeah, I actually went through, pulled one of the images. I pulled the PyTorch one, and I was actually very impressed at the fact that on my disk it was 5.18 gigs. You said it was 3 something.
Yeah, that's the compressed versus the uncompressed, I believe.
Okay.
Yeah.
And then I also did want to mention, if you are on, if you're using a Mac with an ARM chip, when you're pulling images, add the platform flag platform. I had to add platform Linux /x86 _ 664 to pull the AMD
Yeah, I think
version.
we're only building because it's in beta. I think I will say for our images, we build for every architecture by default. But I think for these, I think there was a constraint or something. So, but hopefully we'll have more architectures supported, if not by the beta, by the end of the beta, then like shortly after. That's my hope.
Yeah,
But
but still,
these are really challenging images too, I will say. I mean, that's also no criticism to the NVIDIA team and the the PyTorch team, because they do an amazing job. And these are difficult images to put together. So I'm really happy with our engineering team. I mean, they're pretty good for a beta. But
yeah, I was pretty impressed. It's 5 gigs is pretty small considering.
yes, for that, yes, specifically. I want to say uncompressed. I could try to do a Docker inspect right now, but I want to say off the top of my head, the official is going to be run you something like I think it's 5 uncompressed. Theirs is 5 compressed, so I think it's maybe 6 or 7 uncompressed is where it's at, and it's more stark with the NeMo one. So I didn't, I said 17 gigabytes, but the NeMo one uncompressed, it's almost 40 gigabytes, which is pretty huge. And it even becomes a problem. Like, I mean, we have a high enough up here, but it has 250 gigabytes SSD, and at some point you start. It actually starts becoming an issue that like these things are too big to reasonably do things on your laptop anymore.
Yeah.
So cool.
Cool. Well, let me close out by sharing my screen again. So let's go back here. So just to close out, thanks Patrick for all the useful information and really good kind of starting point in terms of getting these images pulled and actually using them either in your Kubernetes clusters or otherwise. So I think it's a good kind of starting point. And we were talking about the kind of node sizes and kind of how those can get quite bloated as well. So not the images themselves, but the Kubernetes nodes. And so we've it's interesting because we've had 2 meetings now in the past just few months that are around kind of resource optimization. And so so yeah, I mean, if you're interested in that, that seems to be a popular topic for our type of meetup. Come join us. So we're meeting at the Capital Factory downtown in Austin every 4th Thursday. So I don't have my calendar in front of me, but it's the 23rd, I believe, is the last Thursday of the month, essentially, at the Capital Factory. We have that scheduled. So check that out at the katesaustin.com link, and there's free food and drinks, so that's always that's always a good incentive. Here are some of the photos from past events where we've had talks. You could see the one in the middle there is about the kind of the cost resource allocation based on the costs as you're running these CUDA images on your Kubernetes cluster. You start to see the cost go skyrocket quite a bit. So it's very important. We are looking for additional speakers. It's kind of the first time that we've had kind of a backlog of speakers. So we are booked out a couple months, out from now. But if we're always accepting speakers, so if you'd like to talk, and talk in person, more specifically, you can either give a short talk or a workshop at one of our meetings. So just go to katesaustin.com/present, and you can submit your talk via Sessionize. So that's the easy way to do it. And then we're Kate's Austin everywhere on socials, including we just got added to the Blue Sky platform as well as Mastodon. So we're starting to branch out and just kind of do these testing things where we see who's out there and who's interested. So everyone's welcome. And we're on CNCF Slack as well. So cloud-native.slack.com, and we're in the channel Austin community group.
Awesome, and thank you for inviting me, and hope everyone in Austin's doing well. And maybe I'll like to be there in September, so maybe I'll see you guys.
Oh, awesome! Yeah, definitely look us up. And thanks for your time. I really appreciate you presenting today. And we'll have this on the recording, so we'll make sure to share all the good bits from your talk.
Awesome. Looking forward. Have a good one.
Have a good one. Bye.